Hello guys, welcome to Staad tutorials. In this session we'll be dealing with a rectangular water tank. So initially start Staad Pro. Select new project. Select space, give it as some name. Let the units be meter and kilonewton. Select next, finish. Now you go to geometry, select run structural wizard. Select frame models and bay frame. Now you give length as 5 meters. Number of bays will be 1. Height as 13 meters. Height as 10 meters. Number of bays will be 3. First 2 bays will be of 4 meters. The last one will be 2 meters. Then width is 5 meters. Select apply. So in this way. Now you transfer this model to main Staad Pro screen. View it in 3D. Remove the grid. You can see it. Now that we need the entire rectangular tank in the form of slabs. So using surface meshing, we'll create plates. Select quadrilateral meshing. Since the length is 2, in order to have equal parts, give divisions 2, 5, 2, 5, similar to the length. Select apply. You can see this is all our plates symmetrically. Now similar for the other one. Then for the other plate, quadrilateral meshing. You can even select add 4-noded plate option and form the plates by giving right click and generating mesh. However, we need at the bottom too, so select the bottom nodes. Here you will have all the divisions as 5. So it is clear that the plate is of 1 by 1 meter. Now going to properties, select define, select rectangle, give 0.3 by 0.3 for beams on upper side of the tank and lower side, and 0.4 by 0.3 for columns and downward beams, and let the plate thickness be 0.2 meters. Before assigning this, you need to merge all these individual beams. So go to front view, select all the end beams, then go to geometry, select merge selected members, select merge all the members, close. Now you can see they are all as a single part of a beam. Now applying the property 0.3 by 0.3 to those beams. So selecting those beams, assigning to those selected beams. Now selecting the next property 0.4 by 0.3, assigning to the remaining beams. Coming to plate thickness, using plate cursor, you select all the plates and assign to the selected plates. Now you can view the 3D model. As you can see, then going to support, select create support, fixed support, select the fixed support, assign to bottom nodes, view it in 3D. Now coming to loads, well, we have basically dead loads and wind loads or earthquake loads. We will be taking wind loads. So select load case details, select add, select dead load, select add, wind load, X positive, X negative, Z positive, and the last one as Z negative. Coming to dead load, select add, first will be self weight, select add, then coming to pressure due to water, so select plate loads, select hydrostatic pressure. So this is what we are going to apply, but before that you need to see the directions. So this is global directions, this is global Y, global X and global Z. While using plate cursor, you select a plate, give right click, select new view. Okay, you can view this entire plate in a new view. Now give right click, select labels, you go to, you select plate orientation, select apply. See, this is the orientation for the plate, which is local Z, local X and local Y directions. So the pressure will be acting in this direction. So you can select this icon to display the whole structure. Now that you can see the directions, all you need to do is apply the load, keeping in mind the local XYZ directions. Select add, select plate loads, select hydrostatic, then select plates. Where you select to front view, select the end plates, select done. Now interpolation, the load interpolation will be along global Y axis downwards, and the direction of pressure will be this side, in this way. So it is positive Z, that is local Z direction. So give it as 20 and 0.001. Select add. As you can see, the load is applied. Now going for another plates, select the other side plates, select done. As you can see, the Z direction is inside, so here we need to give -20 and 0.001 interpolation along global y-axis. Select add, then close. Now you can view it. See, the pressure will be acting in this direction for this side wall, and for this side wall it will be acting in this direction. Now going for the remaining two sides of the rectangle, hydrostatic, selecting plates, go to this view, select the end plates, done. Now as you can see, the Z is outside, so we'll be applying load this side, so we need +20 and 0.001. The interpolation direction will be y-axis. You can view it in this way. Then coming to the last one, this end. Since you can see the Z direction is inside, so we'll be applying here -20 since the direction is opposite, and here will be 0.001, direction is y. Select add, close. Well, you can view in this way. In this way the pressure is applied for the 4 rectangular concrete walls. However, water pressure will be acting at the bottom in the bottom plate, so you need to apply in the bottom plate too. So select dead load, select plate loads, pressure on full plate, which will be -20. Since you can see the direction for this is upwards, but we need to apply the load downwards, so the direction will be -20. You can either give local Z or global Y direction. This is global Y direction. In negative direction -20 requires, and coming to Z, local Z downside. So add, close. Now you need to assign this to the bottom plate. So select the bottom plates and assign to the selected plates. So you can see the load is applied. Then going to wind load, you need to define the wind load. In order to remove this, you give right click, go to labels, remove plate orientation, select apply, OK. Going to definitions, you find wind definition, select add, wind 1, selecting wind 1, giving intensity 1.5, and height will be 4 plus 4 10 meters plus 2 meters 10 meters. You can calculate building structure will be tank, other similar structures. Basic wind speed is 100 taken. Select apply. OK. Select add. Factor will be 1. Select add. Close. Select the factor using node cursor. Assign to the selected nodes. Now you can apply wind load. Select add. Go to wind load. Factor will be 1. You need to give range 4 meters to 10 meters. You can see it. Then coming to negative, the factor will be -1 and range will be same as the previous one. Here the direction changes. Coming to wind load in Z negative direction, you need to select Z direction and give factor as -1, and the Y range will be similar to the previous one. Well, now that you have applied loads, you need to go to design tab, select concrete, select IS456, define few parameters. FC will be 30,000, F5 main will be 4,15,000. Similarly, secondary reinforcement to 4,50,000, 15,000 kilonewton per meter square. Now going to commands, select design beam, select add, design column, select add, design slab element, select add, take off. Select FC 30,000, select geometry cursor, assign it to the entire geometry. Similarly, primary reinforcement and also secondary reinforcement. Then coming to design beam, you need to select beams parallel to X and Z direction. Coming to column, you select beams parallel to Y direction. Then coming to slab element, using plate cursor, you select all the plate elements. Once this is done, you go to analysis, but here self weight is not applied, so you select self weight, using geometry cursor, assign it to the entire structure. Now go to analyze and print, select add, close, select analyze, run analysis. Well, the analysis might take time since lab element is involved. So you can view output file, the concrete design, beam, then comes columns, and then comes slab reinforcement element. Go to post processing, select OK. Well, you can view the deflection, but before that we go to modeling and apply some load combinations. Select the factor 1.5 and send these two loads on the other two sides. Coming to next load combination, you select 1.5 dead load minus wind load x negative direction. So send dead load to the other side, then select minus 1.5 as factor and select wind load negative and send it to the other side, select add. In this way, similarly for Z positive, you select the factor 1.2, now that you have added few combinations, you need to analyze it once again. Then you can go to post processing mode, view the deflection for different combinations. Then comes beam stress. You can view even bending moments and shear forces, axial force. Coming to plate stress, you can select the type of contour you want. Well, let us select maximum obsolete. Select apply. Okay. You can view the contour. The type of plate stress acting for Brown is 0.897 Newton per mm square. Coming to beam stresses, you can view in summary the maximum values. Fx will be 405.878 kilonewtons at node number 2 for load combination 6. Similarly, for beam 22, minimum Fx is obtained. In this way, critical values are obtained. Coming to force details, you can obtain here. Even graphs are present for individual beams. In plate, you can select any load combination. Well, you can view the contours in this way. You can even obtain the reports later on. As been said in the previous class, you send the Java info on the other side, select output and select whatever the info you want in the report. Send it to the other side, select OK. Well, the report will be created for you. In this way, a rectangular tank is designed. This is the end of the session. Thank you.